Good morning. I'm Pratik Biswas, and I'm an associate fellow at Verizon AI&D. I'm located in New Jersey, in USA. And my presentation today is titled as Large-Scale Summarization of Chat Transcripts in the Absence of Annotated Summaries. Now, since I have only 12 minutes, I will keep the content on each slide at a high level and avoid some of the more technical details, which, however, you will find in the paper itself. So I start with chat transcript summarization and related issues. So text summarization is the process of condensing a piece of text to fewer sentences while still preserving its original content. Now, the chat transcript in this context is a textual copy of a digital web conversation between a caller and a receiver. And the transcription is the process of converting that web or digital conversation into storable plain text. And in this presentation, I will confine myself to chat transcripts that are created from digital web conversation between customer and agents of a phone company. So automatic summarization of chat transcripts in this context, or in our context, pose 6 unique challenges. Okay. First of all, they are not continuous texts, but include conversations between customers and agents. Secondly, they are of indefinite length. Some are very short, some are very long, and they often contain irrelevant, meaningless sentences. They include several ill-formed, grammatically incorrect sentences. They are either unpunctuated or improperly punctuated. And there's a dearth of a large collection of human-crafted, annotated summaries, which could be used as reference summaries for as part of training samples. And lastly, but not the least, existing open source summarization tools, whether they are extractive or abstractive, don't work very well with our chat transcripts. And in case of abstractive summarizers, there is not enough training sample, a large enough training sample for them to fine tune. So, and that's the main reason why the abstractive summarizers don't perform well. So we address these challenges by proposing a hybrid strategy, and our main contributions are threefold. We have integrated topic modeling in embedding-based sentence selection with transformer-based punctuation restoration for extractive summarization through a 10-step sequential procedure. We restore punctuation in the summaries of unpunctuated or ill-punctuated chat transcripts. And we have fine-tuned powerful transformer-based language models on indigenously extracted summaries for abstractive summarization of chat transcripts through transfer learning. These summaries can be very useful both as historical records as well as reminder messages for prior chats. And these messages could be just transmitted through SMS to the concerned customers. So we propose a two-phased hybrid strategy for chat transcript summarization that includes extraction, fine-tuning, and abstraction. So phase one involves extractive summarization. So here in this phase, we use an indigenously developed extractive summarizer to extract good quality summaries from a set of chat transcripts to create a large enough training sample with extractive summaries. And in phase, as you see in this diagram at the top. And in phase two, we use several fine-tuned, pre-trained language model-based abstractive summarizers. And we fine-tune them on the extractive summaries generated in phase one. And then we fine-tuned, we use those fine-tuned abstractive summarizers on the unseen chat transcripts and generate abstractive summaries through transfer learning, and in the process identify the best abstractive summarizer. The abstractive summaries are generated with the tacit understanding that they would be as good as the extractive summaries on which the language models were fine-tuned, with fewer grammatical errors due to the pre-training imparted in these language models. So we come to phase one now. The phase one involves sample generation through extractive summarization. So we have developed an extractive summarization technique that uniquely integrates channel separation, document pre-processing, topic modeling, similarity-based sentence selection, transformer-based punctuation restoration through a 10-step sequential procedure. The 10 separate steps are shown in this figure. I'm not going to go into the details of each step for the lack of time, but the details are described in the paper. I will just mention here that punctuation restoration is actually applied in two steps, step 2 and step 8. So at step 2, we pre-process the original transcripts, throw away existing punctuations, if any, and just restore simple periods, simply the periods, or we call this partial punctuation restoration, so that the sentences could be separated and the important sentences could be extracted down the sequential procedure at a lower further down in the sequential procedure. And in step 8, we actually restore both partial as well as full punctuation to the extracted summaries so that they become more readable. And the output of this procedure is the fully punctuated summaries. Step 2 involves abstractive summarization through transfer learning. So here it involves three steps, primarily three steps. At step 1, we fine-tune pre-trained large language model which LLM driven transformer-based abstractive summarizers on the extractive summaries obtained from phase 1. So we have primarily used 4 language models here, namely T5, BERT, long format to Robata, and dialogue LED. They are all encoder-decoder models. And one thing to note here was this work was started about 3 years back, when these were the state-of-the-art transformers for this kind of work. BERT was most commonly used those days for dialogue summarization, and long format to Robata because many of our chat transcripts are long documents, and dialogue LED because it came out to improve dialogue summarization. So in step 2, we use these fine-tuned abstractive summarizers, which we have fine-tuned on based on the extracted summaries generated in phase 1. We apply this on unseen chat transcripts, maybe as part of a holdout test set, and generate abstractive summaries. And at step 3, we evaluate these summaries using commonly used metrics, and I'll describe them later, and find out which is the most effective abstractive summarizer for our chat transcripts, and then ready it for production deployment. Experimental setup. So we retrained, fine-tuned, tested the transformer models on NVIDIA Tesla A100 GPU-based nodes. The driver node used anywhere between 1 to 4 GPUs. In phase 1, we tested our extractive summarizer on a data set consisting of 160,000 chat transcripts, covering a wide range of issues, including billing, refunds, upgrades, service, outage, maintenance, etc. We compared the performances of our extractive summarizer with those from another very popular open source extractive summarizer, namely BERT extractive summarizer, or BES for short, using 3 pre-trained transformer models, namely BERT, GPT-2, and XLNet. And in phase 2, the 160,000 transcripts, primarily the channel separated customer and agent transcripts, with their corresponding extractive summaries from phase 1, were split into 3 sets, train, test, and holdout, with 150,000, 5,000, and 5,000 samples respectively. We fine-tuned the pre-trained T5 BERT long format to Robata and dialogue LED models on the train and test sets for abstractive summarization, and validated the summaries on the holdout set. So this is all about the experimental setup. So we evaluated the summaries first through manual evaluation. So how did we do that? We took the results from our extractive and abstractive summarization process in the 2 steps, the 2 phases, and then provided the summaries to our customers, which were mostly internal business units in Verizon, and we asked them to evaluate these summaries. So for 50 or so chat transcripts for which they had generated manual summaries, they compared the results of our extractive summaries with those summaries that they had created, and they found that they matched quite aptly. And when it comes to the abstractive summarizers, the feedback was that the summaries were readable, generally comparable to the extractive summaries, and mostly expressed the main information content of the original transcripts. Now, they also concluded that if the chat was about one problem, then 80% of the transcripts were capably summarized. Finally, punctuations greatly improved the readability of the generated summaries, and they were very helpful for our customers. Automatic evaluation. So we evaluated our summarizers automatically for effectiveness and efficiency. For measuring the effectiveness of our summarization and for comparing performances amongst the extractive and abstractive summarizers, we've used two metrics, namely Blue and Rogel scores. For the efficacy of our punctuation restoration algorithm in phase 1, we have used a metric called punctuation restoration accuracy score, which we defined as the number of matches of punctuation symbols between the compared texts, where the compared text could be the original transcripts or the extracted summaries on one side and the punctuated transcript or the punctuated summaries on the other side. And we express this, this match as a percentage. And that's what represented the punctuation restoration accuracy score for the summaries or the punctuation restored transcripts at step 2. In phase 1, we have, when it comes to efficiency, for phase 1, we compare the efficiency of our summary generation process with that of the BERT extractive summarizer by comparing the total time taken by each summarizer to summarize all of chat, customer, agent transcripts in the 160K sample. And for phase 2, we compare the efficiency of the 4 abstractive summarizers by their average training times on customer and agent transcripts.
So we need to conclude very soon.
Okay, so now next we come to the results, and this table shows the results from phase 1. And if you look at it, the row marked in green, it shows that our extractive summarizer generated chat, customer, and agent summaries with higher average and Blue and Rogue scores as compared to BERT in 1/5, 1/7, and 1/7 of the training time of the time taken by BES in summarizing the transcript separately in the 3 cases. We also did an ablation study where we removed the channel separation component and transcript and summarize the transcript, extractively summarize the chat transcript in its entirety. And we found that the extractive summarization with channel separation generated more coherent summaries as compared to the without channel separation. And the customer summaries were the most effective. Lastly, punctuation restoration accuracy scores for chat, customer, and agent transcripts varied anywhere between 90 to 100% in all cases, which means basically we restored 90% of the punctuations, whether it was the original transcripts in step 2 or the extracted summaries in step 8. This shows the results from step 2. There are 2 tables here. So table 1 represents the abstractive, so the metric scores for the 4 different abstractive summarizers. We compare our all the customer and agent abstracted summaries with their corresponding extracted summaries for computing the Blue and Rogue scores. And as you can see, BERT was the most effective and with the highest average Blue and average Rogue scores while taking the least training time. We also did an ablation study where we applied the 4 pre-trained models on the holdout test set without any fine-tuning to understand the impact of fine-tuning on the pre-trained models. And we find this table shows the results. It shows that without fine-tuning, or in other words, it's through zero-shot learning, long format to Robata performed the best when it came to the Rogue scores, whereas the dialogue LED performed the best when it comes to the Blue scores. We also, on an average, fine-tuning improved the performance of an abstractive summarizer.
We are
8 times, on customer by 5 times, and on agent transcripts by 11 times.
Yes, quickly we can conclude.
Just one more. So there are 2 limitations to this approach. One is related to the evaluation procedure, and the other is to capability. We didn't have enough 160,000 manually crafted reference summaries to compare our extractive summaries with. So we compare our extractive summaries with the original transcripts. But that was the case, same with both the compared extractive summarizers, both our summarizers as well as BES. The idea was to see the extent of overlap between the extracted summary and the original transcript. And the results showed that our summaries overlap more in terms of content with the original transcripts. And the other was the limitation due to its capability. One challenge was to repair grammatical errors. We didn't fully repair grammatical errors, only reduce their numbers with fewer sentences, some people post-processing and abstractive summarization through pre-trained language models. Lastly, this research was started several years back prior to the advent of the latest generation of prompt-based all-purpose decoder transformer models like GPT, Chat GPT, Llama, etc. And hence we use slightly earlier generation of LLMs. But the approach still remains the same, irrespective of which models we use. And we have also seen now that even if we use this latest generation of decoder transformer models, they would still need fine tuning.